Hello, I hope this video finds you well. Today we're going to look at a 2013 problem called From 1987 to 2013, and it's a J3 problem. This is a wonderful problem because it highlights, or requires that we use this wonderful algorithm where we can access each digit of a number. And so, I think I want to highlight that technique because beyond this problem, that's a really common technique you see show up in a lot of beginning programming contests. I've seen it on the AP exam as well. So, problem description. You might be surprised to know that 2013 is the first year since 1987 with distinct digits. The years 2014 and all of these each have distinct digits. 2012 does not have distinct digits since the digit 2 is repeated. Given a year, what is the next year with distinct digits? So our input specifications are the input consists of one integer y, where y is between 0 and 10,000, representing the starting year. And the output specifications is the output will be a single integer d, which is the next year after y with distinct digits. So for example, if we take the sample input 1987, we should get 2013, because that's the first year with distinct digits. 999, we get 1023. Again, that's the first year after 999 with distinct digits. Now, before I actually solve the problem, what am I going to do is I'm going to make a definition or a function, and it's going to be called isDistinct. And what this function is going to do is it's going to take a single parameter x, which is an integer. It's going to return true if x has distinct digits, as defined in the problem. It's going to return false other if x does not have distinct digits. So if we pass it isDistinct 1987, that's going to return for us true, if I could type. And if we say isDistinct 999, that's going to return to us false, because obviously there's more than one 9 in there. And so to do this, I'm going to start off by making an empty list nums. And this is going to store each digit from x. So the first thing we do is I'm going to pull out each digit and put it into nums. And I'm going to use this wonderful little algorithm here. We're going to say while x is not equal to 0. And so I'm going to keep doing this as long as x is not equal to 0. And it requires two steps. The first step is I'm going to take nums and I'm going to append to nums x mod 10. So what does this do? Well, when we mod any number by 10, we take the units digit. That is the ones digit. So this takes the units digit of x and appends it to nums. Well, if I run it now, this loop's going to go on forever. If I pass x that is, not 0. Because it's just going to keep taking number and we're going to get a really long list. So I want to get the next digit, and to do that, I use something called integer division. And integer division is when we divide and we chop off the decimals. So if I integer divide any number by 10, we slice off the units digit. So let me just show you a little example here. If I take something like, 345. Okay, we'll say that x is 345. When we start, nums is going to be equal to an empty list, and when I say 345 mod 10, that's going to give me 5. And then, so now I have the 5's digit, which I add to nums. So nums now has 5 in it. So then we say 345 integer divided by 10, and that's going to give me 34, because when we divide 345 by 10, we get 34.5, but we integer divide, so we chop off the decimals. And we say, is this not equal to 0? And that's true. So then we say 334 mod 10, which is going to give me 4. And then I say, I add that to my list, so nums is going to get 4. There we go. And then I say 34 integer divide by 10, which is going to give me 3. And I say, is this 0? And the answer is no. So I say 3 mod 10. And that's going to give me 3, which I add to the list, and so I get 3. And then I say, okay, well, then I say 3 integer divided by 10, which is 0, and say, is this 0? And the answer is yes, so therefore I exit the loop. And so once this loop is done executing, I now have this situation where nums is now filled with the digits from that. So I'm just going to take this and get this out of the way up here. Some people might find that useful. Maybe I'll use that in class to explain it. Alright, so we're going to come down here. So now I have this list of nums. So what I'm going to do is I'm going to say nums.sort. And what this is going to do is this is going to obviously sort nums. So if I have this situation where I have 5, 4, 3, when I sort it, I'm going to get 3, 4, 5. Now the question is, why did I do this? Well, I did this because by sorting the list, that means if I have two of the same digits, they're going to be next to each other in this list. So what I can do now is I can write a loop for I in range. Let's put a bunch of enters in here. I can run a loop, and I can loop it from index 1 to the length of nums, and I'm going to increment by 1, and I'm going to say if nums at I, that is one of the nums I'm looking at, if that's equivalent to nums at I minus 1. So the reason I've started at index 1 is because I'm going to start at this index, and I'm going to say, hey, is this one the same as this one? And if those two match, I know that it's not distinct. So what do I do in that case? Well, I return false. And then this is one of those situations where it's such a benefit to be in a function, because when I return false, it just stops the function. So what I can do now is, if I make it out of the loop, I know the digits are distinct, and I can return true. So let me show you how this works. So if I say is distinct, and I pass it 1987, and I save this, and we pop this up. Oh, I should actually print this out. Let's print the value so you see it. Print. And I save this, and I run it. I get true because 1987 has distinct digits. But if I change this to, say, 1988, I get false because now we have those repeating digits. And before I go on and finish this problem, I just want to say how rich this is as a little piece of code. There's so much to dissect in here and break down. And often I find programmers that are just kind of in the early days of programming are trying to do really more complex things. Taking the time to break this down and understand it is really important, and I encourage you to do that. Okay, so now how can we use this? Well, what am I going to do here is I'm going to start off, and I'm going to make a variable num, and I'm going to take an input from the user, and I'm going to cast it to an integer, because in the Waterloo contest, that's what they do. They just, when they test the program, it's just taking input from the console. And I'm going to increment num by 1. And the reason I'm doing this is I am looking for the next distinct digit. Because if I don't increment by 1, my algorithm's going to actually, and num happens to be distinct, my algorithm's going to return that value, which is not what I want. So now I'm going to make a variable called distinct, and I can tighten this up quite a bit, but I'm spacing out the code so it's a little clearer, and I encourage you to do that. Sometimes we try and write really tight code. It's nice to pull things out so it's easy to read. And I'm going to say is distinct, so I'm going to use that function we just wrote, and I'm going to pass it num. So this is going to return true if it's a distinct number and false if it's not. And now I'm going to put a little while loop in here, and I'm going to say while distinct is equal to false. So basically, if I check the number that I've just passed in here and it's not distinct, I want to loop again. Well, what do I want to do? Well, I want to say num is equal to num plus 1 because this number, the last number didn't work. And I'm going to say distinct equals is distinct, and I'm going to pass it the new num. And so this loop is going to loop until we find a distinct number. And then when all that's said and done, I just print out the number, and that's it. So if I save this now, and I come in here, hopefully I haven't made any mistakes. If I put in 1987, there's my 2013. If I put in 999, there's my 1023. And that's it. So this is the problem here. Again, points I really want to kind of draw your eye to is learning how to write a function that actually takes an integer and slices out each digit is a very important function to get comfortable with as a young programmer or a beginning programmer. And this is a nice example of abstraction where, as opposed to writing this inside the code here, I pulled it out and just put it inside my own function that you know, if someone's looking at this, they just say, oh, it is distinct. I know what that does. Anyways, as always, if you have any questions, please don't hesitate to reach out, and have a wonderful day.